Hi, this is Silvia Mazzoni, and in this video I'm going to show you how to download and run the new NGA-Subduction ground motion model tool. We've done the update for 2022 only to the Excel files. The old versions of MATLAB, Python, and R are still there, but some updates were made to both the KBCG and the PISBA model, as well as I've added the AG20. But that's only done in the Excel file, as well as the ground motion web portal. This is a main page for the tool that describes what the tool does. As I told you, it's got the 3 ground motion models implemented for the 5% damped elastic response spectra. And here's how to cite the tool. I will update the DOI as soon as we get one. Let's click here. This click is going to take you to a form that's going to ask you some basic information, which we're just collecting so that we can contact you and know the type of users that we have. So you click here and you fill out this form. So you put in your email. So I'm going to put in, this is my email, my name, my title. My title is not Miss or Doctor, but I'm a project scientist. So it's useful for us to know what level you are within your organization. And this is UCLA. I'm in California. If you're in a different country, then you just put the country. I do structural engineering work in the academic, and this is just a test. Then you submit the form, and now it gives you the link to the Google Drive. Now you could just share this link with your friends, but we'd appreciate it if you could actually fill out this form so that they can also be contacted directly. So we click here. And now it's redirecting us somewhere, and it's going to take a little bit of time depending on your network. So you want to go to this bottom here and download the file. Give it time to download onto your computer. Once you've downloaded the file from the web, you're going to want to open it. What I want to show you though is that this is a really large file because it's got a really large number of coefficients for the epistemic uncertainty for the KBCG model. So I really want you to be patient. As you can see here, it takes a little bit of time to load up the file, even to my computer. You may find yourself with a security risk for this file because it is a macro-based file. And so what you need to do is you need to go to where your file is located. And here it is on My Folders, and you right mouse it and you look at Properties. What you find is you scroll down in Security, it says it may be blocked because it came from another computer. Just unblock it. And then you apply and you click OK. So now maybe you may just need to reopen this file. As I said, it will take a little bit to open up. Now I get the question again as to what enable macros. I said go ahead, and now it works. And you can change the input as you wish. The first time you open this up, you're going to end up right here on the main page. And this is something you're familiar with. I've tried to make it as similar to the NGA-Subduction spreadsheet and be able to add things to it. So you've got the user input on the left-hand side, and I'll go through this. And then you've got the output on the right-hand side, and some plotting. As you can see, we'll zoom out and there's a lot more data there. But I really want to focus on the very first part. The very first thing you need to do is you want to go and look at the documentation for the spreadsheet. The documentation for it is the actual reports and papers that have been published. They talk about the models, the limitations of the models, the model ranges, and where things can be applied. So make sure you look these up and you read these carefully before you run the spreadsheet. So I've broken up the input into just different parts. I've put in the very first part is things related to the scenarios. Then we've got the weight of the 3 models. As much as this is the most important part, typically we have the same weight on all 3 models. So I put it in the lower part. So we've got region, we've got pull down menus. Whenever I can, I will put in a pull down menu. So these are the different geographic regions that we have in the NGA-Subduction database and the ground motion models. Then you've got the subducting slab. This is something I want you to look up, but it's pretty straightforward because again, this is based on geography, where your site is for considering for your scenario. But I think it's important to see how the model uses this value. And it's really used to compute the magnitude break value for the PISBA model. We've got the moment, BS30, rupture distance. Then we've got these 2 input parameters. This is the fraction of the RRUP in the back arc, okay? So it's broken up into what is the distance. For Japan, we also have a third region, and that is why this is broken up into these two input parameters. Again, I highly encourage you to read the paper to see what these input parameters are. This is the top of rupture distance, the hypocentral depth. Event type, again, this one here is a pull-down menu. Z1 and Z2.5 values. These are used to represent also whether the basin parameters are included or not. I do have a basin structure input here because the KBCG model wants to know whether you're in a Seattle basin or a non-Seattle basin. When I have a no basin selected here, I actually internally set the values of Z1 and Z2.5 as -999, which means that no basin term is computed or is computed differently. Again, you have to look at the individual models. But when I do the weighted average here, I set those values to -999. When I actually do the individual models, I just follow whatever the input parameters are for that model itself. Then I've got, oh, and this is an adjustment value for AG22. Read what it's about in the documentation. These are the three different weights. You're used to seeing weights as normalized, but I don't like to do that because if I kind of want to turn one on and off, then I'd have to put in, 0.333. Then here I'd have to put 0.333, and then one of these I'm going to have to make this be 0.34, and I never know which one to pick. So what I do is I just let the computer normalize it. And so it's kind of handy because if I want to turn off AG, I just put a 0 there and I don't have to recompute half and half, okay? So again, it minimizes chances of error. For now, let's just set everything to 1. This is for computing the epistemic uncertainty, whether you include it in your aleatory variability or not. Again, this is something important to read about. And then this is for computing the epistemic uncertainty for the KBCG model. I would recommend using 100 here, but you better accuracy or better representation if you go all the way to 800, but that is going to slow down your analysis. And then this is the number of sigmas above and below the median that you get from here. So right now I've got a value of 1, which is the 16 and 84 percentile, but maybe you're interested in a sigma value of 2, so you put it in here and it recomputes and it shows you here what that value is. But that's why I put these at the bottom, because these are things that you don't really change too much. So these are the input. I try to put in an error comment here to minimize the chances of user error. Here on the right-hand side of the window is pretty straightforward. Values are, as you can see, I'm no longer referencing cell values. I'm actually using names for these different input parameters, okay? So it just makes this a lot easier to understand and follow. I wanted to show you, most importantly, how I compute the median and the median plus or minus 1 standard deviation. And it's given down here in the documentation itself. All right, first thing I do is I compute the median value and the sigmas. And the sigmas, again, are defined below. So once I've computed the median value, I then add it to the n times sigma. And this is how I do it. You take the logarithm of the median plus or minus n times the sigma, and then you take the exponent of it. And that gives you the median value plus or minus 1 standard deviation for each ground motion model. If I want to compute the weighted value, then I take each one of those, I bring it back to a logarithm, I multiply it by a weight, I add them all up, and then I normalize it by the sum of the weights. That's why if the sum of the weights is 1, then I'm dividing by 1, or whatever value it is, it's normalized. And then I take the exponential of that, okay? So remember, all the values are all done in the natural log space. And then we can see the response spectrum as well as the PGA and PGB values. Please note that the AG model does not compute a PGB value. So if I turn these 0 for the other models, you will see that I have no PGB value, okay? And it's just set to 0. So when I compute the weighted average for the PGB, it's actually the weighted average of the other 2 models. If we scroll over here, you'll see that I've got 0. I can't do -999 because then it throws off my medians and averages and values. And so I just return 0 for the PGB for AG22. I'm going to zoom out here a little bit and show you that this spreadsheet, actually this tab itself, is in 4 parts. So you've seen the first quadrant, which is the input and output, but then on the bottom left quadrant, I've tried to put in as much documentation to help you as possible. Again, this does not replace the main documentation of the reports, but it's just there to give you some good ideas about the quantities. On the right-hand side of this worksheet, I have on the top a tabulation of all the components. So I've got the median, the tau, the phi, the aleatory, which is really the sum of these two, the SRSS of those two, epistemic, and all these different components of it, okay? Because then these I take and I plot them below. I do it for the KBCG model, PISPA, and the AG model. If we scroll down, you'll see that in these plots. So the very first plot on the left-hand side is the same as what you have above. This is the weighted average. But then I'm plotting the three different models separately, and I'm plotting the median value as well as the epistemic uncertainty and the aleatory variability in one plot for the three models. And then in the lower part, I'm actually plotting the individual quantities. So I'm comparing the median between them compared to the weighted median, as well as the median plus or minus the total sigma, aleatory, and epistemic. So I put these in mainly because I was checking the components, but I think it's also a good way for you to understand how these different models work. Also, if you want to build your own combination of models, you can actually do it using these tabulated values. But that's the main sheet, and again, the most important part of it is here on the top left-hand side. What I've also done is I've added a second worksheet. This one gets fun, this one gets busy, and this one takes a little bit of time to run each time. It doesn't take up that much space. So because Excel computes things real time, I've actually put in a flag here to go ahead and update this whole worksheet or don't. The first time you open up this worksheet, you'll see that it's off, and then you want to make sure you turn it on. So here what I've done is I've ran scenarios, but then what I wanted to do was look at the effect of period, magnitude, VS30, and distance, as well as region and basin or no basin effect. This is the input I've tabulated, and then you hold the set constant. So for example, here you hold the scenario constant, you change the periods. Here you hold the scenario constant and the period constant, which you've selected initially. And then it's going to vary the magnitudes in a certain range. And I do this for all three models, and you see the different components of all three, as well as I'm doing it for interface and then interslab. So what you could do is if you want to do this at 2 seconds, or maybe let's see what it's like at 1 second. Okay, and if you look down here, you'll see that it's calculating and processing things. In the meantime, I'm going to try to zoom out and show you this is all the data that is here. You can look at the numbers themselves, compare them to your own implementation. But then, of course, I put this all into plots. Now I've zoomed out too much. And you have to give it, because I changed the period, it's recomputing things. So here's all my plots. Top row is interface, bottom row is interslab. I'm looking at the effect of the periods, the three models separately. And then I keep this period constant, and I look at the effect of magnitude, distance, VS30, and region with basin. And then the quantities that I'm plotting are the median, the spectral value, so median plus or minus the sigmas, and then the sigmas themselves to see how they vary with these different parameters. And it's kind of fun because it really gives you insight into how the different models represented differently. Why am I doing this? Because not all models apply to your specific case. And so it's very important that you understand how these models work so that you see what the limitations are, whether you should be using them or not, or also why you're getting the results that you're getting. And so that's why I've put this spreadsheet together, is to pretty much get us a really good understanding of how the NGA-Subduction models work. And again, you can just zoom in to make sure that when you're done with the spreadsheet with this table, you turn this off just so that it doesn't keep on updating. And then you go back to the main and work with this.